So in this video, we are going to be talking about Lewis dot structures. So in our last video, we talked about electron dot structures and how to draw them based on their valence electrons, things like that. And Lewis dot structures are very similar. However, it's about an actual compound, so more than one element that's been bonded together. And so what we need to look at is how do we know if a Lewis structure is drawn correctly? Can we analyze and look at a structure and know, yes, that's drawn correctly, no, it is not? And there's a couple things that you need to look for. So let's take a look at this first. So we have this structure here. We have this structure here, and we have this structure here. Okay, now only one of these structures is drawn correctly, and so we need to know which structure is drawn correctly and what are the steps that we should be looking for to go through. So the very first thing that you want to check out is whether or not it is supposed to be ionic, which means they have no shared electrons because the electrons are transferred, or if it's supposed to be covalent, which means that you should see shared electrons. Okay, and so there are a couple things that we need to know in order to distinguish this. So an ionic compound has a metal plus a non-metal in it, or a polyatomic ion. Okay, but we're mostly going to be focusing on like metals and nonmetals in this video. And then covalent compounds are all nonmetals. Okay, and so one thing that we need to know as well is, how do I know if the picture is showing shared electrons or unshared electrons? When you have a line connecting two elements, so for example that double bond or this single bond here, those lines represent shared electrons. And so a line, that's still on highlighter. One line is equal to two shared electrons. So that's going to be really important for us to check. So let's run the first test by each thing. So, also you should know this from our last unit, but on the periodic table you have the staircase. Anything to the right side of it is a non-metal, and anything to the left side is a metal, including aluminum. Okay? And so that's how we look at that. So carbon is a nonmetal, and so is oxygens. So this should be covalent, and it does show shared electrons through these lines in the center. So test number 1 is checked off. It's showing a covalent compound. Now in the middle structure here, calcium, Ca, is a metal. Oxygen is a nonmetal, therefore it's ionic, and we look and we see no shared electrons. All the electrons are on one or the other, so that is showing correctly. And in the third structure, we have nitrogen, which is a nonmetal, and hydrogens, which are nonmetals. And so all nonmetals, it should be covalent. It is showing shared electrons, so that's good. It passes our first test. Okay, all of them do, in fact. Our second test, however, is to count all available valence electrons and compare to the structure. The reason why is if you have, for example, 12 electrons available for bonding, but your picture only shows 10 or it shows 14, then you have an incorrectly drawn picture. So if we do this for our first structure, carbon dioxide, 1 carbon, 2 oxygens, we know that carbon has 4 valence electrons because it is in group number 14, and each oxygen atom provides 6 electrons, so this gives us a total of 16. So when we count in the picture, we count 1, 2, 3, 4, 5, 6, 7, 8 dots, and then 10, 12, 14, 16, because each line is worth 2. So the picture shows 16, it should have 16. That is a match. Okay. For the ionic compound, you don't have to count electrons that way, or, well, you can, but calcium provides 2, oxygen provides 6, there should only be a total of 8, and all 8 are around calcium. So that's shown correctly so far. For the third structure, nitrogen is in group 15, so it provides 5, and each hydrogen provides 1, but since there are 3 of them, the total of 3, so you get 8, and there are 1, 2, 3, 4, 5, 6 drawn, so there are only 6 in the picture. So it is incorrect because it has an incorrect amount of electrons. So this one is incorrect, has an incorrect number of electrons. The third thing you want to check is the octet rule. Now, with the octet rule, it says that all atoms need 8 valence electrons, except for hydrogen, which only needs 2. Now, this rule also looks a little bit different when you're looking at ionic compounds. For ionic compounds, the cations should have 0 valence electrons, and your anions should have all 8. Okay, because your cations should have lost electrons, whereas the anions should have gained a few extra. So you'll have to double check that with your ionic compounds. So we've already determined why the third structure was incorrect, so we're just going to stick with number 1 and number 2. So if we look at the first structure, we need to count that all atoms have access to 8. Now in a covalent structure like CO2, some of them are shared, and so when we count our electrons, they count, like for example, these between oxygen and carbon count for both oxygen's octet rule and carbon's. That's why they're being shared. So oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8. So that's good. Oxygen has 8. Carbon has access to 1, 2, 3, 4, 5, 6, 7, 8. So that's good. And this oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8. So that one's good. This structure passed all 3 tests, so this is a correct structure. That's excellent. Now, if we look at the middle structure, it's ionic, and so we know that that affects things differently. Here, we see calcium is our metal, and metals are supposed to be ionic. And they are supposed to, calcium normally would have 2 valence electrons, and so it's going to lose those 2, not gain additional ones. So this one is incorrect because how it should look is it should look like this, where calcium has 0 electrons around it, has a positive 2 charge, and oxygen as our non-metal should have gained 2 extras and should have a negative 2 charge. And so that is what we see wrong with the structure. This is how it should look. So the electrons were swapped. Our metals should be our cations, and our non-metals should be the anion. And so these are the steps that you need to do to go through and analyze a structure. And so hopefully you find this helpful and useful for your homework. Enjoy!